Before we completely end, I wanted to give you a couple of tips about the worksheet that you're going to be doing for today. So in this worksheet, you have a couple of different lenses, and you need to use the lens maker's equation to figure out the focal length of both of these lenses. So the first lens that you'll be looking at is a biconvex lens. So it's a lens that looks like the one in the picture. So you have two surfaces that both kind of stick outwards, and so the lens looks like this. And we want to use the lens maker's equation to figure out the focal length of this lens. And we're told that both sides of the lens have a radius of curvature of 20 centimeters. So that means both R1 and R2 have a radius of curvature, or have a magnitude, which is equal to 20 centimeters. So how do we go about using this lens maker's equation? Specifically, what do we do for R1 and R2 in terms of sign? So if we first want to find R1, then that means we're looking at the front side of the lens. So this is the side that has to do with R1. Now, if we completed this into a total circle, we would see that the center of curvature of this front side is somewhere here. So this would be C1. This is the center of curvature for the front side of the lens. Now, we notice that this center of curvature is in back of the lens, which according to our sign convention, a radius of curvature that points towards the back of the lens, so here this is the same radius of curvature, of course, is here, but this radius of curvature is associated with the center of curvature in back of the lens, and so that means R1 is going to be positive. So R1 is positive 20 centimeters. So then what about R2? Well, R2 has to do with the back surface of the lens, which is this surface. And if we continued this surface around into a complete circle, we would notice that its center would be somewhere over here on the front side of the lens. So this is C2, and the radius of curvature 2 goes from any spot on this circle to this center of curvature. So since the center of curvature is on the front side, then the associated radius of curvature is negative. So R2 is negative 20 centimeters. So because R1 is positive and R2 is negative, when we plug it into the lens maker's equation, we have a 1 over R1, that's positive, minus 1 over R2. So we have minus 1 over a negative number, so those two negative signs are going to end up canceling, and so we'll end up getting a positive focal length. So then what about the diverging lens? Because in the worksheet we also have to figure out the focal length of this diverging lens. So the diverging lens is a biconcave lens. It looks something like this. So it's a biconcave lens. Here's our principal axis through the middle. And so if we want to find R1 and R2, first we have to know that the radii of curvature have an amount of 15 centimeters for this lens. So for this lens, R1 and R2's magnitude is 15 centimeters. And once again, we need to figure out the signs. So for R1, we look at the front surface, this surface, the first surface of the lens. And this front surface curves around, and if we complete the circle, we can see that its center of curvature is here in front of the lens. So this is the front side of the lens. Its center of curvature is here. So its associated radius of curvature, R1, its associated radius of curvature is, since it's in front, is going to be negatives, because whenever we have a center of curvature in front of the lens, the associated radius of curvature is negative. So this is going to be minus 15 centimeters. Then we look at the back side of the lens to figure out what R2 is. And if we continue this side around, then this center of curvature will be back here. And so since this surface has its center in back of the lens, the associated radius of curvature R2 is going to be positive, because whenever a center of curvature is in back, the radius of curvature is positive according to our sign convention. So R2 is going to be a positive 15 centimeters. So then when we plug this into the lens maker's equation, we have 1 over R1, which is negative. That's going to give us a negative number, minus 1 over R2, which is positive. So that's subtracting off or adding another negative number. And so overall, the focal length will turn out to be negative.